Lesson 10, Precalculus with a textbook by Larson. We're on Chapter 2, Section 2, Polynomial Functions of Higher Degree. Okay, so polynomial functions. What we're going to do here is do transformations to sketch the graphs of them, use the leading coefficient test to determine end behavior of the graphs, find and use the zeros of the polynomial to sketch it. So looking on down here, there's a word you should learn. Make a flashcard for it if you need to, but continuous means that you can graph the whole graph with a pencil without lifting up the pencil from the paper. So for example, the one on the left here, I can trace over the whole thing without picking up my pencil. The one on the right, I got to pick my pen up to draw over here. So there was a gap right here. So it's not continuous. On the next page, the library of parent functions continues on. We did in the last lesson the quadratic function y equals x squared. And so now we're moving on to y equals x to the third. So the domain and range of this are infinite for x to the third because it's going forever up and down, and it's going forever to the left and to the right. So it's going forever in both directions. It's going slow, I agree, to the right and to the left, but it is going forever. And there's no domain issues. There's no numbers that you can't put in for x. So anything that you plug in works in this function. So it's infinite. It's got one intercept, 0, 0. It's increasing from the left to the right. When you look at the graph and you trace it, it's going uphill. So it's got a positive slope here and a positive slope there. So it's forever increasing. It's an odd function. It's got symmetry with the origin when it's odd. And again, what that means, it's got the point xy. For every point xy, it's got the point negative x, negative y. So for the example, we've got the point 1, 1 here. We've also got the point down here, negative 1, negative 1. So wherever you have one point, you have another pointer. For example, we got the point 2, 8 way up here. We've also got the point negative 2, negative 8 way down here. All right, on the next one here, the first one, they'd like us to sketch the graph of y equals x cubed and the graph of g. Describe the transformations from f to g. Okay, so what happened on this one from this being f of x being x cubed? Inside with the x, it's minus 2. So remember that whenever you do something to the x, you're going to do the opposite. So you'd think you'd go left 2, but no, we're going to go right 2. So the graph goes right 2. And because of the minus 3, which is outside the x, it affects the y. So we're going to go down 3. Okay, so the original y equals x cubed function, it's got the points negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, 8. Let's see how I can do drawing it here. Score, I did good. All right, so the new one, what happens if you want to use the chart? You went right 2, so all the x's have 2 added to them, and we went down 3, so all the y's have 3 subtracted from them. So add 2 to all the x's, so that's 0, 1, 2, 3, 4. And over here, did I add right? I feel like I did it. 2, I think so. And then all the y's, you're going to subtract 3 from them. So that makes that negative 11, negative 4, negative 3. And then minus, let's see, 1 minus 3 minus 2. 8 minus 3 is 5. So let's see, 1 minus 3, yeah, negative 2. And then adding 2 to them, yeah, I did that right. All right, so 0, negative 11. And then we got 1, negative 4, 2, negative 3, and so on. But if you didn't want to use this method of it, you could have taken all the points and you go right 2 and down 3 with them. So right 2 and down 3, right 2 and down 3. So that's another way you could have done it. All right, let's see if I can do better, do okay drawing it here. Nailed it. Kinda, pretty much. Looks okay. All right, onward. So the leading coefficient test. On the leading coefficient test, here it is. As x moves without bound to the left or to the right, the graph of the polynomial function eventually rises or falls. So if n is odd, if the leading term is odd, like we'll say maybe 3x to the 7th, if that's the leading term on it and it's positive, it looks like the left. When it goes without bound to the right and to the left, that's what the end behavior is. On this one, if it's negative, so maybe negative 3x to the 7th, then since it's negative, it flips it, and as it goes without bound to the left, it's going to rise, and as it goes without bound to the right, it falls. When it starts with an even number, like let's say 3x to the 6th, when it's even and it's positive, it's a quadratic. It goes up on both sides. It rises to the left and to the right. If it's negative, it flips it upside down, and it's going to fall to the left and to the right. So on the next page, we have the leading coefficient here is negative x to the 6th. So the degree is 6, which is even. The coefficient is negative 1. Since it doesn't have a coefficient, it's a 1. So that means since it's even and it's negative, when it goes without bound, it's going to be a quadratic function that's upside down. So that means that it falls to the left and it falls to the right. It falls both ways. And we can double check that on our calculator. So turning it on here, let's see, y equals 1 minus x to the 6th. And let me fix my zoom. I can tell already it's messed up. All right, so that's what it looks like. So it falls to the left and it falls to the right. So as the graph goes without bound, it's falling to the left and to the right, to infinity on both sides. Okay, the next one, the leading degree is 3 with a coefficient of 1/3, which is positive. So the degree is 3, coefficient of the leading term is 1/3, which is positive. It doesn't matter that it's a fraction. It matters whether or not it's positive or negative, and it was positive. So since it's positive, the graph of it, when it goes without bound, it's going, let me see here, it's going to go up to the right. Oh, that's just horrible. And it's going to go down to the left. Let's see what it actually looks like on here. So y equals 1/3 x caret 3 plus 5x. Now it looks like it's a line. You and I both know it's not a line. So let's go to zoom. Go down to zoom fit, which is choice 0, which is after 9. Hit enter, and it's going to fit it to the graph. That's the zoom fit function. And so there you go. So like I said, that's a better sketch there of it. So to the left it falls, and to the right it rises. All right, on the next one, we got the leading degree here is 2 and the coefficient's 5. So overall it's going to make a U shape that goes up. So it's going to rise to the left and the right as it goes without bound. But overall their question on this one has changed. They want us to find the zeros algebraically, then graph it, and then use the graph to find any zeros approximately to check our work. So to do this algebraically, the first thing I'm going to do is factor out a 5. Then you need to think, does that factor anymore? And that doesn't factor. So since it doesn't factor, to find the zeros, we're going to have to do the quadratic equation on it. So b is -2, so that makes it +2. And then b squared, -2 squared is +4. Let's see, -4 times a times c. Then over 2 times a, and a is 1. So that gives you then overall 2 plus or minus the square root of 8 over 2. And the square root of 8 is 4 times 2. So that makes it 2 plus or minus 2 radical 2 over 2. Or that's 1 plus or minus radical 2. You got to divide both of those by the 2. Don't leave anybody out. And then if you were to do that find out the actual number, you could do it one of two ways. You could do it by graphing it. Let's do it by graphing it. Or you could just find the number by going 1 plus the square root of 2. Okay, so let's graph the new one. 5x squared minus 10x minus 5. Oh, and I need to change my zoom, put it back on standard. There we go. And notice it goes pretty far down, so I'm going to change the window right there to go down for the y minimum. I think I'll make it negative 15. Okay, and so if we wanted to, we could find the 0 by going second calculate the 0, choice 2. Remember, you go to the left, hit enter, then go to the right, hit enter, and enter again, and it's at negative 0.41. So from the calculator, we've got a 0 is negative 0.41. And let's find the other one. So again, pick a point to the left, anywhere to the left, go to the right, hit enter a couple times, and it's positive 2.41. So negative 0.41 and positive 2.41. And then we should find what this minimum is here. So second, calculate the min. So I'm going to go to the left and then to the right. So that's at 1, negative 10. All right. I think we did everything. We got the zeros. Yeah, we got it all. All right, on the next page, it's the same question again, so we're going to practice some more factoring. So on the next page, factoring on the first one here, we can take the letter t out. So that makes t to the 4th minus 6t squared plus 9. And then you kind of have a quadratic still because you've got 3 of them, and the powers go up in the same order as it would with the quadratic. This one here is double that one, so it'll work. We can factor it. So t squared minus 3, t squared minus 3. Negative 3 times negative 3 makes the plus 9. The inner and outer terms make the minus 6. So again, you set your factors equal to 0 to solve it. So on the second one here, when you solve it, you get plus or minus the square root of 3 for both of these. And the square root of 3 is 1.7. So positive and negative 1.7 and 0 was a 0 for it. And then it says we're supposed to graph it. So putting in our calculator, we got x caret 5 minus 6x, oh shoot, I hate it when I do that. So x caret 5, and then minus 6x to the 3rd, and then plus 9x, graph. So ideally, to graph it well, I told you should plot the max and min, so we should find that relative min there and the relative max right there. So second, calculate the min. So go to the left, hit enter. Go to the right, hit enter. And the minimum is at negative 0.77, negative 4.46, and the relative max then, go to second, calculate the max, pick a point left, go over it to the right, and the relative max is at 0.77, 4.46. So we'll plot those two. 1, 2, 3, 4. So negative, and then 1, 2, 3, 4, somewhere there. So notice that the radical 3 is there twice, the positive radical 3, so that means it has a multiplicity of 2. And the negative radical 3 was there twice, so it has a multiplicity of 2, 2. And then the 0 was just there once. So these were the zeros. And these were the approximate zeros. Well, I didn't find them on the calculator. Well, we'll find one. But like I told you, it's 1.7. So again, second, calculate the 0. So I'll go to the left of it here. Oop. There it is. And then go past it to the right. Enter and enter. And it's at negative 1.73. And the other one's going to be at positive 1.73. So I think that covers it there on that one. So when when k is odd, the graph crosses the x. When it's even, when the multiplicity is even, then it touches it for repeated values of it. So since it touched it there, it had a multiplicity of 2, and same thing here. If it touches, it has an even multiplicity. If it crosses it, like right here, then it had an odd multiplicity. Again, touched it, so even multiplicity, crosses it, odd, even. All right, so solving this one, it's the same question we just did. They want us to find the 0. So finding the 0 here, doing it by hand, take on a negative 1, which makes x squared minus 49, and that factors into x plus 7, x minus 7. So it's got two zeros, 7 and negative 7, and they both occur once, so they don't have a multiplicity at all. And you can check it on your calculator. Again, it's negative, and so it's going to go upside down through the 7s, and it's going to go upside down. And if you're going to graph it well, again, you need to hit the max. So we'll find the max here real quick. So 49 minus x squared. So the max is really high up there. So it's going to be at the vertex, which is probably, it's at 49. So that's going to be hard to graph, but it's way up there at the number 49. So we'll just say 49 right there. Last page. All right, so on 56, it's the same idea that we've been working on. We're going to factor it first. We're going to take out an x squared. And that actually factors again into x minus 5 and x plus 4. So it has 0 and has an even power, so it's 0 multiplicity of 2. Got 5 and it's got negative 4. Those both have a multiplicity of 1, so you don't bother writing anything. And the leading degree was a 4, so it's going to make a U because it's got a positive 1 in front of it. So it's going to make a U shape going up. And let's double check what this looks like. I got a feeling it's going to be a little interesting. So y equals x to the 4th minus x to the 3rd minus 20x squared. That is kind of fun. So it's got two minimums way down there. Let's find them here. So I'm going to change my, maybe negative 50. We'll see how that does. No, I still didn't get the whole thing in. That's so sad. It goes down really low. Let's see, minimum negative 100. We'll count by 10 so it looks a little better. No, let's count by 20s. There we go. Anyway, you get the idea. So it's got the 0 at negative 4, and it crosses it. And it's got the 0 at 0, and it touches it. And it's got 1 at 5. So it goes down, touches it there, and then it goes down pretty darn far. Would have to change the window some more to get to it. But touches and crosses. Crosses means it goes through it. Touches, it goes up. Touches, it goes back down. So when the multiplicity is even, it touches it. When it's odd, it crosses it. Okay, last one. Hopefully we don't want to run out of time on the video here. So it says, find a polynomial function with the given zeros. So what we're going to do here, it says we have a 0 of 1 with a multiplicity of 2. So that'd be x minus 1 and x minus 1. 0 is 4 with a multiplicity of 2. Remember, you always do minus whatever it is. And it's got a degree of 4, so we have them all in. And it falls to the left, and it falls to the right. So that means that it's negative, which means it's going to go down because it's got an even degree, so it makes a U shape. And since it falls left and falls right, we're going to need to put a little negative out here. So that would be the actual polynomial function. And due to time here, I'm just going to say you got to FOIL it out, FOIL these out, FOIL out the other ones, and then you have to FOIL those together. So when you FOIL all those together and clean it up, you get negative x to the fourth plus 10x cubed minus 33x squared minus 140x minus 16. All right. You guys have a good night.